Hello math fans, here's another lesson on factoring. This time we are going to be factoring forms where the last number is negative, which is a very slight variation of the previous lesson where this was a positive. So that you shouldn't be surprised to see that the process is nearly identical. Alright, so for example, we've got a negative 10 here. The way we begin is the same as before. We begin with this last number and we find all the factors of negative 10. Alright, and so we write them all out. And after we have all the factors, all the pairs, we need to find which pair, when you add them, equals this middle number here, positive 3. And so you should quickly find that this is the pair that makes negative 3. So it adds to make positive 3, and multiplies to make negative 10. So these are our factors. So x minus 2 and then x plus 5. So this is the answer. Now we should always check our answer by expanding. So using distributive property, x times x, x squared, x times 5, 5x, negative 2 times x, negative 2x, and then negative 2 times positive 5, negative 10, combine like terms, and yes, voila, we get right back where we started. So again, factoring is this process where we multiply this out. Factoring is the process where we go backwards. All right, we start with something like this, we go backwards and work it into its two factors times each other. Okay, so let's work another example. We've got a negative 9 here, so we start with that. We find all the factors of negative 9, and then we point out the one that adds to make this middle number negative 8. So we have x plus 1, x minus 9. That is our answer. We go ahead and check though, and we do in fact find that this does create the original. So we have indeed successfully, correctly factored this quadratic. One more example. This one's a little bit more complicated because this last number, negative 12, has a ton of factors. So after you've listed them all, you should see that this is the factor that adds to make negative 4 here. So x plus 2, x minus 6, this is the factorized form of our quadratic. We will go ahead and check it again, and yes indeed, that is correct. So we have successfully factored this. Now, of course, there can be some twists and turns. One interesting one is something like this, where there's no middle term. Well, let's see if we can use our process and get an answer anyway. So our process, we look at the negative 9, we find all the factors, and what we really want to do is we want to find a factor that when we add them make 0. We'll make those two factors cancel out. And so this indeed, oops, not that one. This one is the correct one. So we do x plus 3, x minus 3. This is the factor of this. Let's make sure when we multiply this out, we've got a negative 3, a positive 3. Those two cancel out. And so we do indeed get x squared minus 9. So even though there's no middle term here, we can still factor this. And so when do we know that this is, so had this been like a negative 8, this wouldn't have worked out, because there wouldn't have been any factors of 8 that when you add them make 0. And in fact, the only ones that do work out is when this last number is a perfect square. So recall the perfect squares, 1, 4, 9, 16, 25, 36, and on and on and on, 49, 64. So if that last number is a perfect square, then you're going to get a factor where you got two of the same numbers. Okay, and then because this is a negative, one of them is going to be positive, one is going to be negative, so when you add them, they're going to cancel out and make 0. So anytime that you have, and that's called a difference of squares. So that's a perfect square, that's a perfect square. So the difference of two perfect squares, you can follow this same process and get an answer. All right. Let's see kind of a complicated, more complicated one. Now, instead of just having a perfect square in the second term, we have a perfect square in the first term as well. And when that happens, we can still follow our process. What we have to do is we have to factor not only the first term, but the last term. Of course, we want to pick out the term that's symmetrical. All right, we don't want to pick factors like this. These are factors, but we want a more symmetrical choice. And over here we've got the positive 5, negative 5. And if we were to put this together, so now I put the 2x in both of the first positions, I put negative 5 and positive 5 in the second positions. And so this is the factored form of this quadratic. We can check, multiply everything out. These middle terms cancel out. That's the reason why we don't see anything here. And voila, we have our answer. So we can use this process. It's very flexible. We can use it to not only find the original form with a positive b and negative c, but we can also use it to follow the difference of two perfect squares. All right, hopefully that was clear and that you are ready to try some problems on your own.